In this exercise, we compute the annual premium using the portfolio percentile principle. The Get a Life Insurance Company, it sells 10,000 fully discrete whole life insurance policies, each of just €1, and each for the same age 50. Now we're given a couple of things, the value of the complete expectation of life, the second moment, interest rate, and the 95th percentile of the standard normal distribution. And we have to compute the probability that the probability of making a negative future loss, aka a profit, that it has to be at least 95%. So we want the probability that we are better than break even to be larger than 95%. Okay, so let's start with defining some random variables to model this setting. We define random variables to model this. First we set L to be the total sum, total loss, I should say, total loss of portfolio. And the portfolio means the 10,000 whole life insurances. And L is going to equal the sum of I is 1 up to 10,000 of random variables L, 0i, where L0, I is the whole life insurance for just one person. So these are the 10,000 individuals who buy this insurance. And then we say L0i is loss of one policy. And in this case, we have that this is given by the difference between the outgo and the income. And in this case, the benefit is going to be €1, and we have to discount it properly. Okay, 50 plus 1, because it's a fully discrete whole life insurance. But we do have some income, namely the premiums, and these are paid as long as the annuitant, as the policyholder is alive, and this will be paid out accordingly. Now we are going to rewrite this because it will be more useful, especially when we compute the variance. And how do we rewrite it? Well, I'm just going to rewrite the annuity part, because we have seen that this is equal to 1 minus VK50 plus 1 over D, where D is equal to 1 minus V, the discount factor. Now if we isolate this K50 plus 1, we have that it's 1 plus P over D, and then we have one term left, which is P over D. So this will come in handy when we compute the variance. Now, to use the portfolio percentile principle, we are going to need the expectation and variance of the total loss of portfolio of L. And in turn, to obtain that, we need the expectation and variance of each individual policy of L0i. So let's start with doing that. Let's compute moments. Starting with the expectation of a single policy, this is going to equal A50 minus P times A double dot 50, and this is going to equal, using what is given up here, this is going to equal 0.3 minus P times 1 minus 0.3 over D, and D is 1 minus V, and V is 1 over 1 plus 0.05. Okay, and this will give us 0.3 minus 14.7 times p. For the variance, we are going to use the formula we wrote there in red. And so let me write it out. So this is going to be the variance of k50 plus 1 times 1 plus p over d. Now note that the variance of this part is this part here, variance is going to be 0, which is logical because this is just a constant, and the variance of a constant number is just 0. And this, to compute this, we take out the constant 1 plus p over d, we have to square it, times the variance of vk50 plus 1, whose variance is the difference between the second moment of A50 minus the first moment squared. And plugging in all the numbers, it's going to give us that it's equal to 1 plus p over d squared times 0,035. And this will give us the moments for the total loss of portfolio random variable. Because of the assumption of the independent policies, so these 10,000 are independent, we have that the expectation of L is going to be 10,000 times the expectation of a single policy. And we just computed that. It's given by 0,3 minus 14,7p. Similar for the variance, it's going to be 10,000 times the variance of a single policy, which we computed to be 1 plus p over d squared times 0,035. So these will be central in using the portfolio percentile principle, which we do now. Let me make some space here. We'll remove this part. And then, what do we want to compute? We want to compute the premium, that's the goal of this exercise, using the portfolio percentile principle. And what does it say? So we want the probability that the future loss random variable on the entire portfolio is negative. So this, to be negative, this should be at least 95% or 0.95. Now this can be rewritten by subtracting the mean, L minus expectation of L, and divide by the square root of the variance, aka the standard deviation. And we do that on the left hand side as well, so it's going to be 0 minus expectation of L divided by the square root of the variance, and this should be 0.95. And note that we do this because that's the reason of this portfolio percentile principle. Since 10,000 it's quite a large number, we know that this term is a standardization of this L random variable. It's going to be approximately normally distributed with mean 0 and variance 1. So we will write this as z. So then we have that z smaller than this expectation of L, which is going to be minus 10,000, 0,3 minus 14,7 p divided by the square root of this variance we computed below, 1 plus p over d squared times 0,035 and square root. This thing should be bigger than 0,95. Now we are given that the 95th percentile is 1,645, as stated above. Therefore, this boils down to computing the value of p in the following equation. So let me make some space here. And the equation is going to involve this 95th percentile, because this probability being larger than 0.95 is the same as saying that this expression in the probability, which is this fraction 1 plus p over d squared 0,035, that this thing should be at least 1,645, the 95th percentile. Now, if we multiply both sides by the fraction, by the denominator, then we obtain that this is equal to 10,000 times 0,3 minus 14,7 p, bigger or equal than 1,645 times, so the square root of 10,000 is 100. Then the square root of this constant squared is going to remove the square, and then we have the square root of 0,035 left, and then we isolate p. And put all the p's on the left hand side, and this gives us that it's equal to p times 47,000, and then, because this minus is cancelled, and then minus the part of p that's on the right hand side, so that's 1,645 times 100 times the square root of 0,035, and we divide all this by d, and then we have that this should be equal to greater or equal than 1,645 times 100 times this square root of 0.035, and then we have to add the constant on the left hand side, the minus 10,000 times 0,3, and this becomes plus 3,000. Alright, and from here we can compute p. The only unknown here is d, but d is actually known because it's equal to 1 minus v, and v can be computed from the interest rate. And this gives us that p should be larger or equal than 0,0207, which is the final answer. Note that this p is quite small, so it's a quite small premium. And the reason is that we are looking at insurance policies that pay out only €1. Of course, that's a very small sum to insure yourself. And you can imagine that if this were, let's say, 10,000 euros or 100,000, then of course the premium would be much larger. But in this case, we calculated p to be at least this value, which can be interpreted as the value of the premium that the company should charge in order to make sure that they have at least 95% probability of being more than break even, aka making some profit.